Good evening everyone. I am Aditya Ray of group number GR24EC431 and today I will be presenting our work exploring 6G with MATLAB. With the explosion of emerging technologies like IoT, AR/VR and autonomous systems, 6G promises unprecedented speeds, ultra-low latency and spectrum utilization. Our project leverages MATLAB to analyze key components of 6G, advanced waveforms, link level simulation, and hardware impairments in sub-Tcs bands. Our goals include evaluating waveform performance, 2. Simulating link level performance, 3rd. Understanding the impact of hardware impairments like power amplifiers. So let's dive into first part. So this script demonstrates the use of the 6G exploration library for 5G toolbox. So let's start with subcarrier spacing greater than 960 kHz. So this is the output of this part. We are exploring sample rate and transmission bandwidth. And after that we got output as display cyclic prefix length of the first slot 1060, 36, 36, 36. Similar. Second part for resource grids larger than 275 resource blocks. This allows creating a resource grid with more than 275 resource blocks, which is essential for utilizing wider bandwidths such as those defined in the upper 6 GHz band. So this was the output. And for PDSH with 64 QAM modulation, we got the graph like this, which was analyzed for waveform for 700 MHz channel in upper 6 GHz band. And some extended modulation schemes, we got constellation diagram for the 4096 QAM symbols. And for the next part, the script simulates the throughput of a pre-6G link using MATLAB. It leverages advanced 5G features while exploring extended bandwidths and subcarrier spacings beyond the standard 5G NR specifications. So first we have initialized simulation parameters, configured channel estimator, configured simulation diagnostics, and PDSH propagation channel. So this was starting of that part, simulating parameters validated successfully, and now we have configured parallel execution. So first it started executing, then it got connected to a parallel pool with 6 workers. So this was the return true for parallelism. Number of workers 6, number of slots per worker 5, and total number of frames 2.1429. So now let's go to PDSH link level simulation. So this was the result of that part, and this was the required graph for throughput versus SNR. And finally the last part, we were measuring impact of hardware impairments on 6G waveforms. So we were simulating on 128 slots. This was the required graph for TDD allocation. And after analyzing the impairments for and power amplifying modeling, we got output like this. This was the output, low pass filter. And after APCR to study spectral regrowth caused by the non-linear PA model, power amplifier model, we got output like this. This was the output, desired output. And for CCDF, we evaluated the PAPR of the waveform, and our output was this one. And so finally concluding, the MATLAB based exploration highlights the trade-offs between spectral efficiency and hardware constraints in 6G, the importance of robust waveforms like OFDM and DFTs, the need to mitigate hardware impairments in subsystems. So our project MATLAB proved to be the powerful tool for simulating and analyzing these complex scenarios. Our work provided insights that paved the way for further research into the design and deployment of 6G systems. And finally, we would also like to thank our faculty, Dr. Bhupendra Kumar, for providing us with invaluable guidance, resource, and constructive feedback throughout the development of this project. So now finally the contribution part. So the code implementation part was done by me, Aditya Ray. and the research part was done by my fellow teammate Falgun Pal and Shailesh Kumar Singh. They were inclined toward contributing and identifying key technologies and parameters essential for the project success. The documentation part was handled by Abhishek Pathak and AnshKumar Gohil. They ensured that the documentation was comprehensive, technically accurate, and well organized, presenting the project work effectively. So our project was successful by the co-contribution from all the team members equally. Thank you. Thank you.